Hey guys, welcome back. So in today's lesson, we're going to shift gears a little bit. So far in this unit, we've been talking about chemical reactions, and we're going to continue talking about chemical reactions, but we're going to move away from like counting atoms and balancing equations and talk a little bit more about the types of reactions. And specifically today, we're talking about fusion versus fission. Now, this is going to kind of lay the groundwork for tomorrow's lesson, so just make sure you're paying attention as you're taking your notes as always. So let's go ahead and get started today. So there are two different reactions we're talking about today, fusion and fission. The first one we're going to talk about is nuclear fusion. And when we talk about fusion, this is going to be joining two or more things to create a single entity. So in terms of what we're talking about, two light atoms are going to come together and fuse to make a heavier atom. And this is just a little depiction of that happening. So we've got two smaller lightweight elements coming together, and then it's going to kick off a larger atom. Boom, fusion, and then they go their separate ways. All right, so we need to be able to define nuclear fusion. This is the process which produces light and heat in stars, such as the sun, by smashing together lightweight atoms. So when we're talking about nuclear reactions, this is going to be of or relating to the nucleus of the atom. Remember, our nuclei consist of those positive protons and those neutral neutrons. So when we're talking about nuclear reactions, what's going on is taking place in the center of those atoms. So fusion just means to combine or to fuse. So here we have the example of this. This is just the depiction. So we have hydrogen and these two lightweight hydrogen atoms coming together. They collide, and then once they collide, helium is created, which is a heavier atom, and also energy is created. This is going to be very important when it comes to talking about these reactions today, because in both of these reactions, radiation, aka energy, is going to be produced. Okay, so energy is kicked off. The other thing about fusion is that this is a natural process. So nuclear fusion only happens in stars. So when you go outside, and especially in the summertime, and you feel the heat from the sun that's coming down and hitting your face, you feel that radiation. That radiation is made possible because this fusion reaction is happening in our sun, which is that huge star that helps us live and survive on the earth. Okay? So fusion is coming together. That means fission is going to be the opposite. Fission is splitting or breaking down into smaller parts. So instead of taking two lightweight atoms and having them combine into a heavier atom, we're going to take a heavy atom and it's going to split into smaller atoms. So basically just the opposite of what happens in fusion. So nuclear fission is the process of splitting a heavyweight atom like uranium. It's used on Earth for nuclear weapons and produce electricity. So if you guys see here, this is actually a picture of a nuclear power plant. If you've ever heard of, like, Chernobyl was kind of a famous meltdown, but we have nuclear power plants here in the United States. This is the process where you break down a heavier atom. A lot of times it's uranium in nuclear power reactors, but basically what happens is you bombard the nucleus of the heavy atom with a neutron, that neutral neutron. So you kind of force it in there and you force this atom open to split. And then what happens is that the nucleus kind of breaks apart. So it will break down into smaller or less heavy elements, as well as the different neutrons that are being kicked off. So fission is to separate, break apart, or fizzle out. Again, this is used in nuclear weapons, like that Engage video that you guys watched at the beginning of class. Remember, you watched that video and you had to answer the question, what do you think this has to do with today's lesson? This is it. So the chemical reactions that make those nuclear weapons possible is fission. Fission also releases energy, a great deal of it, and radiation. But the difference between fission and fusion, other than that fission is just a breaking apart of atoms, is that fission is man-made. Fission does not occur the way that fusion does in stars. Now, there are unstable isotopes that can break down, and we'll talk about that a little bit more tomorrow. But this here, especially in the production of electricity and nuclear weapons, this is man-made. So we do this on purpose in order to extract that energy. And just the last thing to kind of keep in mind for today, in a fission reaction, remember, if we go back and we look at this diagram where these neutrons are kicked off, when they're kicked off, this can cause kind of a chain reaction, because now once you have these neutrons bumping about, they can continue to run into atoms and further create fission reactions. This is actually what happens in a nuclear reactor. You're bombarding the uranium with these neutrons to continue these fission reactions to create the energy that we want to get out of it. Okay, so that's just something to keep in mind, fission in these fission reactions. Okay, and that's really it for today. There's just a few things to take away. Number one, fusion coming together happens naturally in stars. Fission splitting apart, we do it for energy and nuclear weapons. Both fusion and fission create energy. So they release energy in the form of radiation. All right. And that is pretty much it. It's just a really short intro to nuclear chemistry because tomorrow's lesson is going to be a little bit trickier, but we need to lay the groundwork and know that nuclear chemistry, we're dealing with the nucleus of the atom, and that the atom can break down and change depending on the process that's going on. Okay. If you have any questions on this, let me know. And if not, you guys can move on to your assignment.